Hi all, welcome to ArohiTech in Hadoop series. So today we'll discuss about the introduction of big data Hadoop. Okay, so nowadays people are keep on talking about big data and big data. So what is big data? So if you Google about the big data meaning, okay, so we can have the definition. So it means the big data is nowadays included in the dictionary. So the definition says extremely large data sets, means it is a huge amount of data set, that is called big data. So how much, how much of data we can say it is a big data? That depends upon the situation. Suppose I have 100 GB of data. Okay, so can I say that is 100 GB of data is a big data? That depends upon the some more factors. So the amount of data we can set is a volume. So 100 GB of data, if it is coming with the velocity in milliseconds, then so if in milliseconds 100 GB of data is coming from the different data sources to the warehouse, then yes, I can say it is a big data. And that also should be satisfy some of the conditions. Okay, and we can have like variety of the data like structure, semi-structure and unstructured. So that we'll discuss one by one. So that is that we are focusing here. So here, so the amount of the data which is coming from the different data sources, if it is training to the traditional database systems like RDBMS or mainframe, like it is unable to process and unable to store the data, then that amount of data we can see it is a big data. So coming to the definition purposes by the Gartner, so what it says, the big data is high volume, high velocity and high variety. So if the data having high volume and high velocity, like the speed at which it is coming, like 100 GB of data per milliseconds or 100 GB of data in the seconds. Okay, if that type of data is coming from the different data sources to the warehouse where you want to store the data, so that is also a, we can consider is a very big data. Okay, and high variety in the sense like different data sets like structured data, unstructured data and semi-structured like audio, text, video, all those things and images. Okay, and that should, how can we solve that issue? That we can solve with a cost effective manner. If I have dumped the data, I captured the data, but while implementing the some technique or some technology to give some business meaning to that, if the cost involvement would be more than the like how much cost we have utilized for the resources to get the business, if that is very less, if that is very less, then we cannot say it is a cost effective. So with less amount of cost involvement, if you want to extract or if you want to extract some of the business meaning or very which is very helpful for the for our company's business, then we can say that way we can solve the issue with innovation techniques and technologies. If you involve some of the technologies, some of the very highly innovative technologies nowadays, it is there what we are going to discuss. So if you are integrate with that, and you can solve the big data problem like high volume, high velocity and high variety of data which is coming from the different data sources, and with a cost effective manner, and with high innovative way, if you approach to that data, and you can solve the problem statement, and which is very helpful for the business purposes of the company, and we can get a very good revenue out of that, then the big data problem can be solved, we can say. Okay, it can be solved by the company, and who can solve the problem in a timely manner, who that company will become the market leader. Okay, so this is the definition by the Gartner. Coming to the IBM definition, what it says, the big data is a term applied to data sets whose size or type type is beyond the ability of traditional database systems to capture, manage, and process the data with low latency. So what does it mean? So nowadays, like we can have a traditional database systems like big RDBMS mainframe. Suppose the data is coming from different data sources, and if I want to store the data, if I want to process the data, but if my traditional database systems will giving the strain, it will not happening properly, or it is giving the processing capabilities with a very huge amount of time it is consuming, and I'm not getting the proper output in a proper time, then that type of issue is coming by the traditional database systems. So that type of data we can say it's a big data, even though the data set is like 1 TB of data, but still if 1 TB of data cannot be handled properly by the traditional database systems, we can say there is a big data problem. Okay, so now coming to what is the big data, like how can the IBM definition has given with 4 V's, including 4 V's, as already we have discussed, like volume, the amount of data, and the velocity, the speed of the data, at what speed it is coming from the different data sources, and variety of the data, like structured data, unstructured data, semi-structured data, like text file, video, audio, and semi-structure, like you can say the XML file and JSON file. That type of data is coming from the different data sources, and that can be handled by the big data solution component. We will discuss about that. And variety of the data, so suppose I have dumped many data, like I have dumped 100 GB of data or 200 GB of data or more than that. Suppose I have stored in my data source, in my data uh, warehouse. So what will means out of 100 GB of data or 1 TB of data, suppose I need some of the valid data, like if in my problem statement, my present problem statement, if the out of 1 TB of data, if 100 GB of data is being utilized by this problem statement, and this is the valid data, okay, so that we can say it is a veracity of the data. So extracting the valid data from the huge data set, we can say it is a veracity, means in this problem statement how much amount of data is required, so that we can say it is a veracity of data. So this all 4 V's defined by the IBM, so we can include many V's as well. Okay, so this is the volume, already we say the V's: volume, variety, velocity, veracity, and value. So value, you can keep on adding more ways, like value. Suppose I have dumped many data, or I can capture the data from different data sources, but if I will not extract the value out of this, so what is the meaning? There is no profit out of my big data, then it is not, it is a meaningless. Okay, so that is called value. So I have to extract, as a company, i have to I have to utilize my resources to extract the business meaningful information from the big data, and that should be bring the revenue of the company with a huge profit. Then we can say it is a value addition to the big data. So if I'm not getting the value, then there is no use of the data. Okay, so the like value we can add, keep on adding more weeds, people are keep on adding, and that way they are defining the big data definitions. So before coming why big data and what is big data, I want to say, like one scenario we can take aviation sector, we can take retail market. So these are called data sources. Okay, so now aviation sector, so the plane is moving from one city to another or from one country to another, so it has lot many sensors are capturing the data. Okay, capturing the data, and in the like control station, they can dumping the data in milliseconds, per milliseconds. Okay, per seconds the data can be captured. So this is a very huge data sets. So by capturing the data, they can analyze. Okay, they can analyze the weather forecasting, the weather condition, and what is the crew members are doing, what is the that data can be dumped, and they can analyze what type of service I can provide to the customers to get satisfied, or and to get more business they can attract towards our sector. Okay, to our aviation sector. So that way the analysis will happen by the like aviation sector. If you coming to the traditional, I mean, to the retail market sector, some suppose Amazon is there. So when you want to purchase something, you are navigating to the website, okay, amazon.com, and you can have if suppose if you want to purchase something, just you are keep on browsing, right? So when we are keep on browsing, the logs will be generated in the backend and it can be dumped in the syslog server in the Amazon. So nowadays, suppose there are some trends is going in. Suppose the one example we can take the mobile. Suppose the mobile is coming in the market. Many mobile vendors are there, so they are keep on advertising their own. And in the Amazon store, we can have variety of mobile devices. So now people are keep on purchasing which one is in the trend. Okay, suppose we can take one city example. Suppose one city of the India. So they how many people are keep on choosing, so which product, okay, which mobile model. So suppose that people are keep on browsing, they wanted to purchase that one, so that logs will be dumped in the backend, and the analyze the dump that logs will be analyzed by the analysis by analytics data analytics people in the backend by the Amazon. Okay, so in every company doing the same thing, like those who are involved in the like retail market. So I'm talking about the retail market. So that way they can analyze, they can say that okay, this mobile device is nowadays is very popular and it is browsable by, or it is chosen by many people. Okay, so they can give the category which mobile is having highest demand in the market. So this is called sentimental analysis, one kind of. So that way they can order to their respective companies to supply more and more on that model of that mobile, so that way the retail market people they can do their business very highly. Okay, so now coming to the point, why big data and what is it. So the definition purposes, it is a large data set, as already we have discussed in the like in the Google we have searched, it says the data large data set. So data set to so large and complex that traditional data processing applications like mainframe and RDBMS are inadequate, means it cannot handle properly. Even though they can handle with fraction of the data, but that is not sufficient. And that is okay. So the system which is training with the processing and storage wise, it is not educated, it is not efficient, then we can say there is a big data problem. And challenges include analysis of the data, capturing of the data, data curation of the data, searching, sharing and storing and transfer and visualization, and the information privacy. So these are the challenges with the traditional database systems. So what is data curation? The term is like analysis. You can know how to analyze the data and capture the data. Okay, you can capture from the different data sources to the warehouse. And data curation, so data curation is nothing but organizing and integrating of the data collected from various data sources. So it involves like annotation, publication and presentation of the data such that the value of the data is maintained over time and data remains available for reuse and preservation. So that is called data curation. So okay, data curation. And searching, we can sort the data. Okay, we can search the data. Suppose you want to search the data in the traditional database system, but it will take very longer time. So what is the use? I cannot take the decision in a right time. And sharing of the data, that is also, we can share the data to the public world with a effective manner. Then if the data cannot be shared, data cannot be published properly, then what will happen? I cannot gain the market. Okay, and storage, like huge data is coming towards the warehouse. So if I'm unable to store the data, then there is a big data problem. Transfer visualization, like we can have, you can integrate with the many tools like Power BI and etc. We can have integrate with that and we can visualize. You can, like layman can understand what is happening exactly. So if that cannot be happen properly, then there is a big data problem. So big data is a setup technique and technologies that require new form of integration to uncover large hidden values from the large data set that are diverse, complex and of massive scale. So what does it mean? Like we can have, that is the nowadays the data is called a new oil. Suppose there are huge data sets are there, but if you are unable to extract some of the value addition to the company, then what is the use of the big data? So that is also a problem. So that's why we have to, so to overcome these issues, okay, to overcome these issues, the Hadoop came into the picture to rescue this kind of issues. Okay, it will give a very effective solution to overcome the two types of problems. One is storage wise problem, another is processing wise problem. Okay, so there are a big data buzzwords like the IBM definition. What he says, big data is a business strategy for capturing on information resources. And again, another definition by the IBM, big data is not just a technology, it is a paradigm shift. Means the basic fundamental data structure can be transformed from uh, one view to another view, like how the people are seeing the data nowadays. In one decade before, like 10 years back, if you go, that time the data were there, but that was very less if you compare to nowadays, because nowadays we can have the social networking sites, we can have the aviation sector, we can have the retail market. So huge amount of data can be generated nowadays per second, like how many tweets you are doing, how many Facebook posts you are posting, how many other social networking sites like WhatsApp, many things are there. So we are keep on chatting, keep on uploading, so huge data sets is keep on generating. So this is called a paradigm shift. So 10 years back and now, if you compare, it is a huge difference. And after we can have the huge data set, now people have the mindset how to extract, how to bring this data into the business. That way they can approach. So big data is a novel by the Gartner, and big data market will be growing 7 times faster than the overall IT market. So nowadays the popularity of the big data is so high that every company, they are going to adopt the big data technology. Okay, so that's why we are here. And what is the problem? Two problems arise. One is storage, another is processing, because my data set which is coming from the different data sources is very huge, like Facebook, Twitter, LinkedIn, etc., etc., and etc. And retail market sector like Amazon, Flipkart. If you go for the aviation sector of every airlines, they are keep on generating the data. And sensor, like the IoT devices are nowadays integrated with the many home appliances. So they are also producing huge amount of data. So I wanted to do storage first, and I want to process on the data. So if that cannot be handled by the traditional systems, then Hadoop came into the picture and it can solve both the issues. What is that? Storage and processing. Because storage cannot be handled by the traditional systems. 1 TB, 2 TB is fine. Then more than that, beyond that, it cannot be handled. Suppose you can say, okay, I have the system which can store up to 5 TB. That's fine, but it cannot go beyond. But we can have huge data sets, so it cannot be handled by storage wise. And processing also, it is very difficult to process in a single go in a traditional database systems of 500 GB of data. Also it will be giving some straining, it will give some stress. So for that, and you cannot get the output in a proper time. That's why the storage and processing is very issue, very kind of big issues in the traditional database systems. To overcome that, we can have the Hadoop. Okay, so now this problem who is addressed the first, the Google is addressed this issue, this because they are the search engine companies, like big data problems are there that time also. So that can be solved the first, the first of all, the Google is solved this issue. Okay, he has realized and he has solved the issue by using, by introducing the Google file system in 2003. Because okay, and that can be solved the storage issue because he has developed the distributed file system in 2003, that is Google file system. So storage problem can be solved because they can have integration of multiple of systems, and that data can be distributed across all the system or multiple of systems. So storage problem can be solved by the Google by introducing GFS, Google file system. And later on, like after 1 year, like 2004, the processing capabilities also can be solved by introducing the MapReduce. Okay, that is GFS MapReduce. Okay, Google's MapReduce engine, we can say MapReduce. So that the processing can be solved in 2004 by the same Google. Okay, so now Google is solved, but that time many people, many organizations like Yahoo and some other organizations also keep on struggling about their big data. Okay, they are keep on struggling. So what happens is there is a history how the Hadoop is evolved. Okay, we'll discuss later in our next session, maybe Hadoop history. Okay, so I'm not talking about that nowadays, but okay, some guys realized like Dave Cotting and Mike Caprilla, they both guys are realized and they have implemented the GFS file system to the open source, we can say. Okay, how the project is evolved, all those things we'll discuss in the later session. But for time being, I'm saying that Dov Cutting and Mike Kefla, they both realized on this thing, and they have implemented the GFS file system to the Hadoop file system, like distributed HDFS, Hadoop distributed file system, and they have implemented, and that way the big data is evolved, or the Hadoop ecosystem, Hadoop with lot many ecosystems will be evolved, because Hadoop is the component who can solve the processing as well as the storage. But there are many issues which cannot be addressed by the single component. That's why we can have lot many components or lot many softwares, like we can say it is the ecosystem of Hadoop that is evolved, or that is like invented, like Pig, Hive, HBase, Uji, Spark, Scala, many things are there. Okay, and Kafka. So that is the popular things are there, and there are they keep on increasing the ecosystems, and there that can be integrated with the Hadoop. So Hadoop 1.0.0 is invented or is developed in 2011. Okay, and what are the core components? One is distributed file system, that is HDFS, which can solve the storage issue, and distributed programming framework, that is MapReduce, so which can solve the processing issue. And in 2012 we can have the Hadoop 2.0.0 or 2.0.0. So this is released, so and it is, we can say it is an open source community like Apache Hadoop. We can have the software without any licensing, we can download and you can utilize. So there the core components are distributed file system, that is the HDFS, which can solve the like storage issue, and distributed programming model, that is MapReduce, it is in there, and yet another resource negotiator. So why yet another resource negotiator came into the picture, we will discuss later. Okay, because MapReduce like which can solve the processing issue, but it only depends upon the MapReduce programming model, like only it can support the MapReduce programming. But coming to yarn, it can solve. Okay, the yarn is a component in 2.0, okay, of Hadoop, which can overcome some of the difficulties. It is not depending upon the only the MapReduce programming model. It can be happen with other APIs or other programming languages to solve the processing issue. Okay, to process the data we can write with many languages, but before in the MapReduce, only the MapReduce programming language was satisfied. Okay, that is called Java language. Only Java language is the main in the MapReduce. But nowadays with the introduction of the yarn, it can be happen with many languages, it can support many languages. Okay, in 2017 we can have like 3.0.0 got released, and the same components are intact, like distributed file system, distributed processing model like MapReduce, and yarn as well. So okay, we can say yarn is replaced by the MapReduce is replaced by the yarn. Okay, but still in the backend it is there, it is supported, it is supporting like the old MapReduce will be supported in the 2.0 and 3.0 as well. Okay, so yarn has the very beautiful feature, we'll discuss later in other sessions. So this is all about introduction of Hadoop big data, and this is the history we'll discuss in our next sessions. Okay, thank you so much. If you have anything, you can give a feedback on this. Thank you so much.